everyone, in the previous video we have discussed the Turing machine, that is a raised to n, b raised to n. In this video we are discussing a language that can be done by a PDA. What was the language? A raised to n, b raised to n, c raised to n. Okay, a raised to n, b raised to n and c raised to n. So why it can't be done by a PDA? We have already discussed this type of grammar in the PDA, like 0 raised to m, 1 raised to m and 2 raised to m. Why it can be done by a PDA? Because A is inserted into the stack and matched for word B. Then for matching C, there is no remaining, that is nothing to be remaining for match it for B, because in the stack it will have only word Z0, which we have already discussed when we have discussed the PDA. You better see that video why we can't do that. It can be done by a PDA. So, but here there is no restriction. We are not using external memory. We are saving in the input tape itself, isn't it? So, it will be very easy to do a raised to n or b raised to n, c raised to n in the Turing machine. How we can do? Look at here. I am drawing a tape, that is I am inserting blank as the marker. Here also I am inserting the blank as the marker. Then look at here, I am taking 2 A's and also 2 B's and 2 C's. Okay. So how we can do? In the previous video where we have, when I said a raised to n, b raised to n, I have already said this is the first logic we are using. There's another logic also to do a raised to n, b raised to n. Look at here. When we do a raised to n, b raised to n, that is a and b. Here it is blank and here also it is blank. We have used the logic what I have made this a as x and I move up to blank and make this b as what y. Another thing can be done is I make this a as x and after a, when I see b, I make it as what y. That can also be done. So this logic we are applying here because to get an idea of the both logic of Turing machine, I am doing this a raised to n, b raised to n, c raised to n using the second logic. So look at here. I am seeing when I see first a, when I see a, I make it as x and I move what forward. Okay, so I make a as x and I move a as x and I move forward. Next, when I see b, I have to when I see a, I have to what bypass. Okay, so when I see a, I make it as a and move what forward, because forward to be moved I have to take the next b. So a is matched with next b and then c. So every a there must be one b and one c, or we can say for every b there will be one a and c, likewise for c also. So after a, when you see b, okay, we are using the second logic. I am not repeating up to here. That is, after a, when I see b, I make it as y and I move forward. Okay, so next this b is made by what? Y. Okay, next when I see b, I have to what bypass. So b is seen, I make it as b and move what forward. Okay, next I have to take care of what c. When c comes, I make it as z and I move what backward. Okay, so when c comes, I make it as what z and I move what backward. Okay, that is the condition. Then what will happen? I have to bypass all things in between what z and x, isn't it? So what all combinations come between z and x? B comes, isn't it? B comes, I make it as b and move backward. Then y comes, y, I make it as y and move backward. Then what? A comes, I make it as a and move backward. Okay, then when I see x, okay, when I see x, I make it as x and move what? forward, isn't it? When I see x, I make it as x and move what? Forward. So after forward, I see what our next x will be, next a will be seeing. So I again make it as x. So when I make it as x, next a can be bypassed, or whether it is y has been there, it can be only also bypassed. I have only taken care of what? B. So if y here, I make it as y and move what? Forward. Okay. Next, when I see B, I make it as y and what? Move forward. So I make it as y, and next B is min match, make it as y and move forward. Next, when I see B can also be bypassed. If z is there, that also can be what? Bypass. Z is there, I can move what? Forward, because I want the next C. When C comes, I make it as z and move what? Backward. In backward moving, what all we see? A can be seen, y can be seen, B can be seen, also what? Z also can be seen, isn't it? Z also can be seen. So Z is also what? Bypassed. Okay. So that's way you must check after writing the correct logic. You must check whether you have been anything, you have missed anything for the bypassing condition. That also must be taken care of for the correct working of the Turing machine. After x, Z bypassed, y bypassed, and up to where the machine will reach, up to here, and there is no a's there, it's been correctly matched. So remaining will be what? Y will be remaining, Z will be remaining for blank, isn't it? In the previous video we have checked for the what? Blank condition. When we reach the blank, we say that it has been what? Correctly matched. After all a's, after all x, no a is there, you must bypass y and Z. In the previous video, what we have done, after seeing all a and making it as x, we bypass what? There it has only what? Y, and after y, when we see blank, we have said what? It has been accepted. Here we must what? We have to see y and z also. So after y, I move what? Forward. I make it as y and move forward. Next, any times y comes, okay, whatever times y comes, I make it as y and move forward. Next one, when I see z, I make it as z and move forward, and whatever z I am seeing, okay, whatever z I am seeing, I make it as z and move forward. And when I reaches blank, okay, blank, when I reach, I make it as blank and move what? Forward. Okay, move backward, and it is being what? Accepted. Okay, it is being accepted. That is the logic behind this. That is the logic behind it. That is, every time you see A, you make it as X, and match for the B, make it as Y, and for the Z, we make it as what? For C, we make it as what? Z, and repeat it, and also check for the bypassing condition. After that, after all A's is being finished, the logic or the machine will reach up to here, and when it reach here, you check whether there is only y's and z's in your tape. That is y correct, y's and z's in your tape, and if it is correct, it will it will be what? Blank. If you reach blank, you can move what? Backward. Okay, so that is the logic behind the A raised to n, B raised to n Turing machine. So you practice it, both logic you practice it. In the first video we have said when we reach blank and make the next B as what? Y. In this, after A's, this B is made as what? Y. So practice the both logic. Whatever you find easy, you do that, or you continue with that logic. Okay, so thank you.